With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that there are a large number of pendulum with identical bobs but varying length are suspended from a thick thread. Another pendulum of a heavier bob is also suspended from the same thread as shown in the figure. Now this pendulum is used with the heavier bob is used as a driver to drive the other pendulum called the driven pendulum. So this is the driver pendulum, okay? And these are the driven. These are the driven, and there are several pendulum having a different lengths. Now assume that the amplitude of the driver is maintained constant by some suitable mechanism and let the frequency of the driver be f naught. Now it is observed that now, for example, first of all, we just go into this diagram. So this is one of the pendulum which has been set into vibrations. Okay, so this would be the for other. So this vibration which is provided to this heavier of the pendulum, okay, heavier of the masses. So due to this thread which is attached here, so these vibration would be transferred to the thread itself. And since all these pendulums are attached to the thread itself, so they would be oscillating, or we can say that they would be having an oscillation. So this is the case of forced oscillation. Why forced oscillation? Because for these pendulum we have set a external. So this system would be external to all these systems. So this is the case of forced oscillation. Now whether all the pendulum except one is at rest. So whether all the pendulum would be at rest, this is wrong, because this vibration is transferred to the thread, and these are attached to the common thread. So when thread is in motion, so these would be in motion. Now what will happen? Now we know that since this pendulum is matching its length with this pendulum. For example, if we just see, let's say the length of this pendulum is L, we can clearly see that length of this pendulum is also L. Now we know that frequency is given as to be 1 divided by 2 pi under root G divided by L. This would be the frequency. Okay, and in the case of forced pendulum, if the frequency is equals to, if frequency, for example, this is the vibrating frequency would be equals to the f naught. Okay, now if this length is also having, this pendulum is also having a length L, so the frequency of this would be equals to 1 divided by 2 pi G divided by L in the under root. So we can say that the forcing frequency is equals to the frequency of this pendulum. So what will happen? So for this case, there would be resonance, and it would be having the maximum amplitude. So all would be vibrating, vibrating, but the length, the pendulum which is having the same length would be vibrating with the maximum amplitude. So this option is wrong. All the pendulum oscillate in phase with the driver. This is also wrong. Why? Because initially this would be vibrating and they would be at rest. Then suddenly energy would be transferred to the other pendulum. So its motion would decrease and their motion would increase. So they would not oscillate in the same phase. Now one of the pendulum oscillates with the maximum amplitude. This is right. Now this is one of the right option. Now the pendulum with the maximum amplitude oscillate in phase with the driver. This is wrong. Why? Because, for example, initially this was vibrating, okay, and this, which is having the maximum amplitude, that was at rest. Okay, so it was transferring its energy to this pendulum. Okay, or we can say that to each and every one, but maximum energy was transferred to this pendulum. Now after that, what will happen? Its speed would decrease and its velocity would increase. Its velocity would increase and its velocity would decrease. Why? Because it has transferred energy. Now after that, what will happen? Its velocity would be more. So then again, it would transfer its energy to the heavier pendulum. Why it would transfer its energy to the heavier pendulum? Because it would be in resonance for this pendulum, because they were having the same length. Okay, then their energy would be transferred and its velocity would decrease and its velocity would increase. So clearly we can see that they are not in the same phase. So if they were in the same phase, so they would be having the same velocity at the same instant of time. So the correct option is just the C option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.